Who wants to kick us off with stand up? I know we reviewed yesterday, but what did we review? When did we have light bulb moments? What did we learn? What did we realize we knew that we didn't know before? Where are we at? How are we feeling?
I'm feeling a little stressed out because I'm like, I was thinking about GitHub earlier and uploading my projects and thinking, do I have to put them all in the same repository for them to connect to my portfolio? And if I need to do that, then I'm thinking I need to rename all the index.html files for the other projects and then the JavaScript files as well, and then just make sure that I relink them.
It's up to you. As projects grow, it is more common to see them in separate repositories than to have them all in one mega repository. However, there's nothing inherently wrong with having one mega repository and having all of your projects inside of that. The index.html files will not clash with each other if each project that you're adding to the mega repository is in its own folder. So it is okay to leave them all named index.html. And then if you set up that project to serve through GitHub Pages, you'll actually be able to essentially deploy all of those front-end projects and have them be runnable on the internet. So it is a good idea to kind of go back and retroactively clean up your code and get them up on GitHub so that you can add them to your portfolio.
Thank you.
You fell for the little hook there in the self-assessment form yesterday of, hey, remember that portfolio you built a couple weeks ago? Yeah, you shouldn't forget about that one. Keep it up to date, because what you're going to find is that towards the end of the program, we're going to pick up speed on the capstone, right? And it's going to be more and more about getting work done on your capstone and less about necessarily the independent little projects we're doing in the classroom. And so it's important to stay on top of that, because you're asking to be hired as a web developer, right? Or wherever you end up at the end of the program. You can't say as a web developer, oh, well, I don't really have any web projects, or, oh, I don't have a website. So building that portfolio as the class goes on is going to make it much easier, so that when you are interviewing, your potential employer is able to go on a website and learn about you and see what you have built over the course of the program. Because keep in mind, a lot of employers aren't familiar with a boot camp, or if they are familiar with a boot camp, they may not be familiar with our specific curriculum. And so what that allows you to do is, when an employer is interviewing you and asking you questions, you can go and say, hey, look, this is what we learned how to do. We learned how to build a front end. We learned how to use the Bootstrap grid. We learned how to make things interactive in JavaScript. We are going to learn React. We're going to learn the database. We're going to learn Node. And having each of those independent projects is a great way to show your potential employer, hey, I didn't just learn concepts here. I actually learned how to build projects, and now I want to go build projects for you as a job. What else from yesterday? Did we have any moments where something clicked that it wasn't before? Did we feel like the review was helpful? Did we feel like it was boring? Did we feel like we went too fast, too slow? How are we feeling?
It wasn't too fast yesterday. It was good to go back over. I thought it was helpful to review the stuff that we reviewed.
Awesome. Any other comments for yesterday, or any other comments for what we should do today before we dive in?
Yesterday, just going back through just the general concept of, Java, functions, objects, arrays.
So we want to just be really careful there. We are not learning Java. Java and JavaScript, two completely
Sorry.
separate languages, and you'll get laughed out of a interview if you make that slip up yourself.
True, but my apologies. But in general, just the whole concept just kind of stick yesterday. Made no sense.
Awesome. Yeah, I think part of the exercise, and I was talking to Jesse about this, is that we're learning so many things so quickly that it's easy to feel like we're falling behind because we haven't identified the concepts that we are learning, right? So being able to break them down, take a step back and say like, okay, arrays, what are we doing with arrays? Okay, push and pop in indexes and looping over them, great. Let's put a box around that and assess where we're at our array knowledge. Okay, great. Push that to the side. Now let's move on to the next concept, right? So it's easy to look back at all the daily outlines and go, oh my God, there's so much here that we covered. How do I keep this all in my head? But breaking it down into those independent concepts and saying, okay, what concepts are we struggling with here? And what ones do we get, right? Because it's probably as equally important, if not more important, to say, hey, I'm not actually struggling with a ton of things. There may be more things that I need to identify and work on and find those resources. But in general, there are a lot of things that I'm learning here and have under my belt. So Danielle, totally agree. We are going to do this step every project week now. So we will be reviewing more often, and we will have these self-assessment forms built out for all the independent concepts that we're going to learn in React, which is what's coming down the pipeline next week. And then we will do this all again for Node and SQL and the database as well. So I think for the future cohorts, we're actually going to split this into 4 checkpoints. So we'll do HTML and CSS first. Then we will do a self-assessment on JavaScript, and then we will do it on React, and then we'll do it on full stack database and stuff like that. So we will definitely be building these reviews in. That was the goal of project weeks from the beginning. But I think we just maybe went a little too gung-ho into the projects in the first project week and needed to slow it down a little bit more for this project week to make sure the concepts were sinking in. Any other notes or questions or anything like that before we roll forward?
No.
Okay, so the goal for tonight is to keep the review party going on. We are going to try and take Ryan's 4 days of teachings and boil all of that down into hopefully half a class, right? So we're going to touch a little bit on concepts. I have a quick slide deck with only 5 slides that we're going to go through. It is absolutely critical that you interrupt me and ask questions, right? So if anything does not make sense at any point, either interrupt me or shoot me a message or shoot Karen a message. We definitely want to make sure these concepts are making sense because APIs and networking knowledge are going to be the basis of your capstone, right? We've covered a lot of JavaScript and we've covered a lot of HTML. That is going to be your foundational knowledge. But now we're getting into the core of, hey, we need to start putting pieces together. We need to start using React to build out web interfaces. We need to start using the database to store our data. And we need our API, which is going to be our data link between whatever our front end interface is and whatever our database is, right? And so don't panic. We have not gotten to Node. We have not gotten to databases yet. But if you don't understand necessarily how this data is flowing through your front end, you're really going to struggle with getting your capstone working, right? Because if you don't understand where you're building, getting it to do what you want it to is not going to work. So we're going to go through, we're going to review tonight on APIs. And then we are going to build a little project to kind of use those concepts and understand how things are all interlinking together. If you have any questions that pop up, interrupt me. If you have questions that you think of during the break, shoot them to me and we can cover them after the break. But let's dive in now. So this is a oversimplification of the how a basic API call works, right? Over the internet, there are kind of three places that we covered where we can make an HTTP request. We can either be in the browser and use a method called fetch. And you guys may have played around with doing that fetch in the console or doing it in your JavaScript file in a script.js that's tied to an index.html. That's the first place we can kick off a request. The next place we can kick off a request is a tool called Postman, right? And I know you guys have a little experience downloading it. And then the final place is using curl in the terminal, right? And the goal here is identifying that all three of these are making the same kind of HTTP requests. They're just different tools to make that request actually go out and happen. So we are going to practice with browser and fetch, but also comparing this to Postman and understanding, hey, these are one-for-one tools, right? The data that we're using in one is going to line up with the data that we can see in the other. So curl in the terminal, we're not going to focus on, but this is not an exhaustive list, right? There are lots of different applications that make HTTP requests and different methods of doing it. The three that I labeled here are what I believe Ryan covered. And like I said, we are going to focus on those two. So I said a request. There are two parts to HTTP, right? There's the request of, hey, I would like this data. And then the response of, oh, I am responding to your request with the data that you asked for. So the request is going to a server. Lots of different kinds of servers. The server that we're going to be primarily using is called Node.js, and Express is the framework we're using. Getting to that in a couple weeks. But this request has multiple pieces of data associated with it. The first is the method. The server would like to know what kind of request are you making, right? So you can think of this almost as the type of the method. The most common kind of request is a GET request, a GET. And that GET request, do I have that on the next slide? Yes, I do. Is saying, hey, I would like some data. Please, I am requesting you go get some data and send it back to me in the response. You guys have made thousands of GET requests over your lifetimes. And I know that because whenever you load a web page, when you go to google.com, when you go to newyorktimes.com, wherever you're going, that is a GET request. And if you don't specify the method of the request, it is always going to default to GET. However, GET is a little limiting in that it is only responding with the data, the basic default data. So if you would like to send some additional information with it, you can use the body of the request, right? That is where you're sending up some data to the server. And that could be anything from something as simple as a username and password, or something as complicated as an image or a larger file, lots of different things. But the most common data format that we're going to make that body use is JSON. But there's that missing piece in there, and that's the headers. And the headers is really giving the body context, right? The headers may have some authentication information in it. That may have your username and password. That may have an API key in it. It may be describing the body, and it may be saying, hey, the body data type that we're using here, we're sending you up some data in JSON. Or it may be saying, hey, we're sending you some form data here. It's not coming in as JSON, but this is how you should parse it, right? So the whole point of the headers is to give the request more context into, hey, how is this request actually working? What's in this request? Okay, the request ends up at the server. Now the server has to go process that. It has to figure out what endpoint you're requesting, right? That endpoint is the URL. What URL are we going to? What data is in the headers? How are we going to parse out the body? What are we going to do with the body? Okay, we deal with all of that information in the server. We're going to get to learning that down the road, right? We're going to be building out our own APIs. The important part of all of this is understanding, hey, this API, why are we using this API? It's because the API is the application programming interface, is how we interface our front end code with other people's code on the internet. This is how we go retrieve data and use their specific documentation to pull that data back. Okay, so the server, it does some stuff in the background. We may not fully understand what it's doing yet. We don't know how to build an API, but hopefully we're working our way up to understanding how we can use someone else's API in order to use the data and incorporate it into our front end. So the server does some stuff behind the scenes and says, okay, here is a response. For every request, you are supposed to get a response. The easiest part of the response is some status code. So I did not use this slide, but I think we already touched on headers. The status code is saying is the chance for the server to give you details of how that request went. 200 is the one that we hope for the most, right? A 200 status code is saying everything worked fine. Here's the response to the request that you made. But there are a couple other status codes, and the browsers know how to handle these. So you may say, hey, you're looking for google.com, but we just rebranded and we want to take you to alphabet.com now. Well, 301 and 302 is saying, hey, redirect you over to alphabet.com. A permanent redirect is saying we're never going back to google.com. We're always using Alphabet. A 302 is saying, hey, we're kind of working on google.com right now. Just go to Alphabet temporarily and we'll deal with that down the road. 404, you've probably heard of those. You've heard jokes of a 404 not found. That is basically, hey, you're requesting this thing. We don't know what you're requesting, right? And when you go on any web page and go to some URL that doesn't exist, this server responds back with a 404. A 500 is something that you lose sleep over as a backend developer. A 500 is some generic, something went wrong on the server. It's not your fault. You can't do anything to fix it, but the server just wasn't able to do what you wanted to for whatever reason. Go contact whoever built the API or the web server or whatever it is and work with them. A 503 is, oh no, they're down, right? Something went offline. The server's not working. There's a fire going on at the warehouse, the data warehouse or wherever the server is hosted. Whatever it may be, it's just not available. 504 is, hey, I made a request and I waited a minute and 2 minutes and nothing happened and I never got a response. So it timed out. It just said, we didn't get something back to you. And there is a whole list of status codes. One of my favorite is 418. I'm a teapot because it responded back to a request to make coffee and refused to make coffee because it is a teapot. And I'm not kidding you. This is an actual thing. And if you open it up, there is a whole page on the Mozilla developer network of I'm a teapot and the history behind it. But if you're interested in any more of these status codes, there is a whole list in here and groups of them and all of that fun stuff. Okay. So last part of the response is there are headers that we use in the request. There are also headers that get sent back from the server. And the headers achieve the same thing, right? The headers are trying to tell the browser, hey, what's going on with this response? Give me context. Let me understand what kind of data is in the body. Let me understand maybe how long the request took to make, or maybe you have some authentication information or session information, or headers are just another place like the body that we can put information. But the headers are usually about the request or the response themselves. It's not necessarily where we put in our own information unless it's something like an API key. And the response coming back, it doesn't have to be JSON. The response could be an HTML page, right? It could say, hey, your you're making a request to NewYorkTimes.com, we're going to send you back the HTML of all the different news content. If it is an API response, it's normally going to send data back in JSON, but it doesn't necessarily have to. Some other data formats are XML, which was the predominant data format and data structure before the whole industry switched over to JSON about, I don't know, 10, 15 years ago. So different kinds of data that can be in the body, but we're going to break that down and practice with our fetch tool and our Postman tool to understand how all of those are working. So just a quick note on the body. Body can be used to and from the server, multiple formats that I just touched on. Some methods don't use a body. So the get method does not have a body that you can use to send the data up. Or the GET request also does not really have a body to return the data back. So just something to keep in mind. Okay, after all of that, questions. That was a really big overview. Is anything clicking from Ryan's slides? Is anything clicking from what we do, what we learned last week? Do we have any questions before we dive into Fetch and Postman?
Yes.
Clicking.
Go ahead, Christy.
Oh, no, I said it's clicking. It's definitely clicking.
Awesome.
I was going to ask a question. When we did a fetch and we went to print out the response, is there a difference between printing out the response.text or the response body?
Yeah, so response.text is going to give you the body as it was sent to you, right? It might not be parsed out. It's just going to give you it's kind of like saying .inner HTML. It's giving you just whatever the raw data is. But if you use something like .json, then it's going to parse out the JSON that was in that response and give it to you in an actual JavaScript object. Or you could print out the entire response and not use .text or .json. And at that point, it's going to give you all the information. It's going to give you all the headers. It's going to give you the status code. It's going to give you all of the information that you could dive into. But I would say 98% of the time, I'm going, whenever I have a response, all I really care about is what's in the body. 1% of the time, I care about the status code, and the other 1% of the time, I may need to pull apart the response and get access to some other data that's part of the big mega object that comes back in the response. But the vast majority of the time, all I care about is either the response body or the status code coming back from the response.
Thank you.
Doug, go ahead.
Follow up on Larry's question. So when you get text or JSON from the response, it requires another then. So those functions that generate another promise that material is not part of the request.
Correct. And we are actually going to dive into promises as part of the review. We're going to use both a promise and something called async await. So we can understand that a little bit more of how that's working. But we will get to that in one moment. But in answer to your question, you've hit the nail on the head. Yes, .json, the thinking is that because parsing all of that data could take time, that happens in a promise. So that code is running asynchronously because you may want to go run some other code while your JSON is being parsed.
So does it get parsed regardless, or only if you?
Only if you call the .json method.
Okay, thank you.
Yeah, there are hypothetically times we wouldn't want to parse the JSON if we were making maybe back-to-back requests and saying, hey, go get data from this one fetch API URL endpoint. And when you get that data, just turn it around and make another request and send that data back up to the server. At which point you wouldn't need to parse out the JSON and then convert it back into a string. You would be able to just kind of redirect it right through there. But vast majority of the time, anytime that you get JSON, you would want to parse it out so you have it in an object. Any other questions on this or on any of the slides here? I know visuals can sometimes be helpful, and so taking all of the terms that you guys have learned with headers and methods and all and status codes and kind of just giving it context, I think is really helpful. So if you guys ever find yourself getting a lot of terms thrown at you and not really understanding how they all fit together, try and make a diagram, right? Try and get out pen and paper or your whiteboard and draw it out the way you think it's working. And feel free to send me a picture of it, right? I've got terrible handwriting, so it's nothing to be embarrassed of if you do as well. But sometimes diagrams are the most helpful way of learning this stuff. So sometimes just give it a stab and see if you can diagram it out. And then feel free to send that to me, and I can give you some feedback of whether you're on the right track or if there's a more accurate representation. Okay, last chance for questions before we dive in. We're going to start with Postman and then work our way back to Fetch.
I don't really have a question, but I just wanted to say, like, I get everything and like the functions and everything that's happening, but my thing is, like, I just want to know, like, when would you, or because the examples are helpful but not really helpful. Like, I want to be able to see, like, how exactly would I use this, or like, when would this be necessary to use this? Because I see the information that gets printed out, but I'm just like, how am I applying this to anything? So that's my thing.
Great question for you, and I've got a one-word answer for you. Wow. We are going to use the Owen Wilson Wow API. And this API is a massive database of every time Owen Wilson says the word wow in a movie. And with that, they have put in little clips of every time that he says wow. And they have the audio clips, and you can just click to get another random one and actually see the clip in the movie where he says wow. Yes, this is a crazy example, but the general thinking here is you want to use an API whenever you want to interface with either someone else's data, or you want to save your data into someone else's system or your own API system. So basically, we can't talk to databases directly on the front end. The database is likely using something called SQL, structured query language, or standardized query language. I always forget which one it is. But we can't use a database directly in our JavaScript. We need a web server to be between our database and our front end code in order to make that data flow throughout the whole system. So in tonight's example, what we're going to do is there's this massive database of every Owen Wilson wow ever said or ever recorded, right? And so what we're going to do, because we want to use that data as part of our interface, we're going to use their API, understand their documentation, test in Postman, and then go over to our JavaScript and make that all work. Another time, this is all, I use APIs all the time. One API that I've built out is we build chatbots at work, right? That's primarily what my other job is. And we like to make it contextually aware. So we ask the user, hey, what's your zip code? And then they give it back to us, and we respond back, oh, wow, looks like it's a nice sunny and hot day in Syracuse, New York. Or we respond back, oh, wow, did you know there's a tornado watch going on right now? That's an API, right? Because my company doesn't want to do weather forecasting and maintain the weather and figure out what temperature it is and all of that. So what we do is we use a weather API to go out, to send a request with the user zip code, and then we get a response back saying, hey, the current temperature is this, and the current weather forecast is this, and the low and the high, and all of that detail. Well, we take that response, work with the response, and pull out the pieces that we want from it, and then incorporate that into our conversation that we're having with the user. So lots of different API examples that we can work with there. We're just going to do the Owen Wilson Wow one because it's so whimsical that I think it's fun. It just depends on what kind of data that you're interfacing with. You may not realize this, but you're using an API every day, right? So when you're on Facebook and you go to comment on someone's post, you're making a post request to the Facebook API to add whatever your comment is into the database. And when you reload that page, that data is coming from an API request, and it's saying, hey, here's your friends list, right? And it's listing out all of your friends and your IDs. Hey, here's what to put in your feed, and all of your feed data has all of that JSON in it. You'll be using it in your capstone to say, hey, I'm building out this page, and I may have 20 items that are in my database that I would like to show up on my page, whether that's the mental health resources, and we're giving you phone numbers, whether that's item locations in the aisle of the item names and what aisle they're located in, whether that's bike route locations and the images that are going to show up. All of that is going to be flowing through your API. So again, a reminder that we have not built an API yet, and you should not be panicking about, well, how am I going to do that in my capstone? The only part that we're covering up until this point, and that we'll review in a second, is how do we use someone else's API? Then we will build our way up to how can we more easily integrate API data into our front end, which we're going to use React for. Then we're going to move into how do we store this data in a database and work with it. And then we finally work our way up to, hey, how do we build our own API, and finish up with how do we take our own API now that we've built it and integrate it into our front end. That was a very long response, and I am known for not answering questions when I ramble. Did I help answer the question, Shanjay?
Yes, for the most part. Yes.
You're also what?
I said yes for the most part, yes.
Okay. Okay. So we're gonna use this API tonight. And hopefully that will start to click to make you understand, where do we go from here? The other thing that might be helpful is going back to the weather project. And I'm liking this idea so much that we might actually do it in tomorrow's class, of saying, hey, let's get more practice using an API. Let's go find a weather API and take our weather app that we've already made and make it actually pull in live data. We'll see on that tomorrow, but I do want to go through some review stuff tonight before we get into something like that. Okay. We are going to dive into Postman unless there are any other questions. Okay. So when I pop open Postman, Postman often has the last stuff that I was working on up. Let me see if I can blow that up just a little bit. No, that's not what I wanted to do. Postman has a lot of tabs and has a lot of information in it that we are just going to ignore. Postman is all about just testing out this idea. So what we're going to do is we're going to close any existing tabs that we have open, and I'm going to open a new one here and read through this documentation. So they are saying, hey, we can retrieve multiple wows by using a GET request to this URL. So I'm going to copy that, come back into Postman, and there's all the different methods that we can use. I'm going to set it to GET, and I'm going to put in my request URL, or also known as my endpoint, right? It's an endpoint because it is where we're going on the server at the end of the server to go get this data back for us. So,
should I be should I go get this link as well to follow along with you or no?
I would encourage you not to follow along tonight and just interrupt with questions. There's no homework assignment for this. You do not have to turn anything in. We're just going for light bulbs here. We're not going for assessment and making sure everyone is following along.
Okay.
Okay. So what Postman did for us is it said, hey, you've got a question mark in the URL. When you have a question mark in the URL, anything else following that is what's going to be considered a query parameter. So it is just like an object, we have keys and we have values. In our get parameter, yeah.
I'm sorry, not cutting you. So remember I was telling you, Larry, that I was messing up with the parameters and the header, because if you click on the header part, that's my apologies. There's a part that says the 6 hidden thing. I had clicked that by accident, and every time I tried to enter the authorization, the bearer code, and all of that stuff, it was like confusing me. So I just wanted to point.
Yep.
So I will get to the headers in 1 second, but what Postman is doing for us is it's trying to be helpful. It's saying, hey, we recognize the key here. The equal is telling it the key is done, and then we're seeing the value. And Postman is able to parse that out and give it to us in this user interface. So if we wanted to, we could adjust the number 10 here and see that it's going to adjust in the URL. So now when we hit send, we're going to get all of this data. Now, important to recognize, this little line is separating out all of our request information with all of our response information. So anything going on with the request, the parameters used in the request, the body of the request, the headers of the request are all going to be on the upper half of our screen. And then the response data, the body that's coming back from it, the headers that it's responding from, all of that stuff is going to be on the bottom half of our screen. So whenever you're thinking about your request and your response, just know that, hey, the request body is going to be up here. The response body is going to be down here. And so this API is responding with a bunch of JSON for us, right? And it's saying, hey, the random wow that we found was in the movie Midnight in Paris. This is the year the movie was made. This is the year or the date that it came out. All of this information, how many wows were in the movie, how many wows were in. This is the 4th time he has said wow in the movie, all of that kind of information, right? And it is, but we've got some additional data layered into both this request and the response. If we pull this down and look at the headers and click on that 6 hidden that Wayne was talking about, here's the additional data that Postman is sending up to the API server. The user agent is saying basically what kind of browser or what kind of agent is making this request. Normally, that would be our browser. That would say Chrome or Safari or Firefox. But Postman has its own version of being able to make these requests. So the Postman is telling this API server, hey, we're running Postman runtime, and that version is 7.29. It's also adding in some additional information about like how this connection should work. It's saying, hey, keep this connection alive until the data gets sent back to us, and then you can close out the connection. There are some times that you would actually say, hey, I'm going to send you this data. I don't really give a crap about what you're sending back, so you can close out the connection as soon as you've got this request. I don't need a response. So you could change the connection in here. If you're curious about any of this additional stuff, you can hover over the eye and it's going to give you a breakdown of what all of those headers do. Honestly, the only 3 times I've used headers in a request are to provide API authorization or authentication information, like an API key or a username or a password. We definitely use the body encoding content type a lot. That's to say, hey, server, I'm sending you a body, and in that body, that is formatted using JSON. And then the third time is to look at the user agent. Sometimes we use user agent to debug a user's issue, right? So saying, oh, turns out you're using Safari on the iPhone, and your version of Safari is super old, so this CSS that we use doesn't work. Or, oh, we're using some JavaScript that doesn't work on older versions of Safari. So we will use the user agent in there sometimes, but that is pretty much the extent of the headers. I don't think I've ever modified the accept header or the accept encoding before. But again, content type, content type for the body, authentication and authorization for APIs, and just looking at the user agent to understand where the request is being made is pretty much the extent of headers that I've used. Okay, so that's all for the request. Let's take a moment there. Do we have any questions?
When you make a request by fetch, if you don't manually add those headers, do they get sent with the fetch request?
I don't know the answer to that.
But
I know, I think I can answer that though when we start playing with fetch. Because we're gonna, oh, I don't know if I can check that. I don't know the answer to that. These are the defaults that Postman adds. I can't tell you whether or not fetch adds them by default. I can tell you that they will add user agent by default. So I am guessing that there are some defaults that fetch must add without you having to declare the headers.
okay, I was just wondering if any of them are required that you would have to add manually.
It would be up to the API server to determine whether or not a header was required. And if that header was missing, you may get a response from the API server that would use like 500 error code or a 400 error code. And it would say something like badly formatted response or badly formatted request. I think there's actually a status code for that. 400 is a bad request. So what you would do is on the API side, if you wanted to require a header for some information, for some reason, a good example of this may be, hey, our API works not only with JSON, but we also can accept other data formats coming in. We can accept XML coming in. But you need to tell us in the headers whether or not the data type you're sending in is XML or JSON. So if you send us a request and you need some data, but you don't tell us the content type in the header, we're going to respond with a 400 and say, that's a bad request. You sent us some data, but you didn't tell us what data type that data was.
Okay, thank you.
So yes, it is possible that some headers would be required. You could really get finicky and say, well, hey, fetch should be adding your user agent by default, but if it's not, we don't know that you can trust, we don't know if we can trust you because we don't know what version of the software you're using, or if you're on a browser or you're making an API. We just don't know what you're using. So we're going to just block anything that doesn't have a user agent. Or probably the most common, other than the content type, would say, hey, we require an API key. You can't get any of this data from the New York Times unless you provide us your API key. And so if that's not in either the parameters or the headers or wherever they require it to be, we're going to send you back with not only a 400, we're going to send you back a 401 and say you're not allowed to use this endpoint because you didn't give us any authorization information. Okay, any other questions before we move into, hopefully our body is self-explanatory. We've got our body. The headers were telling us additional information. So what it's telling us is, hey, the content type coming back in this response is application JSON. So what that told Postman is, hey, in the body, we can actually parse this out and show a nice object. Because what the server really responded with was this giant hunk, right? And what Postman did is it said in the headers, I know application JSON is coming back. Because of that, and because I know this content type, I'm able to go to the body and make that formatted nice and pretty for you and do the proper indentation because the server told me what the content type was coming back. And then in addition, we have an X powered by, that's kind of the equivalent of the user agent. This happens to be an Express server, which is the server that we will be learning how to build in a couple weeks. So it's just giving you more information about how that was built. I actually don't know what Cowboy is. Anyway. Okay, any other questions before we switch over to fetch?
On that content line, that, I don't know how to pronounce it, but CHARSET, what does that mean again? Because that's from HTML, right?
Yeah, it's the same. It's called a char set, short for character set. It's basically telling the computer, hey, how do we convert the letters that are coming back in this data into binary and vice versa, right? Because the computer stores everything in binary. So the most basic char set or char set, I've heard it pronounced both ways, is something called ASCII, ASCII. That is like the very basic English letters only, uppercase, lowercase, numbers, basic symbols, and that's all we support. And so you may say, well, why do we need anything more than that? Well, what happens if we use an emoji? That emoji is actually a character. So how do we take that emoji and have the computer encode it in a way that it can get stored in binary? Okay, what about Chinese characters? How do we take a Chinese character? That doesn't fit in the basic ASCII setting. So what this char set is basically doing is it's saying, heads up, when I return some of this data, there may be an emoji in this data, and we need to tell the browser or Postman or whoever made the request, heads up, the letters coming back in this data may have an additional character that isn't part of the basic set, like a Chinese character or an emoji or something like that.
Okay, thanks.
Danielle, go ahead with your question.
Okay, so I get everything that you just did. My question is, can you refresh my memory? How do we connect this information that we're receiving back to our JavaScript?
Great question, and where we're headed next.
Okay.
So, but important to touch on that here of Postman is really meant to be a playground, right? Just like when you were using the console in the browser and it's not saving any of your stuff, that is intentional, right? So Postman is meant to be an easier tool to play around with our headers, to play around with our parameters, to get our authorization or authentication working, just to see that we are getting the data. Because once we have the data, now we need to go incorporate this into our tool. I'm sorry, into our own code or whatever we're building. So Postman is meant to just be an easier place for us to play around with APIs and make sure that we can get the data that we want. And then once we have played around with it and know that that is all working in Postman, now we can add a layer of complexity and jump into our code and make that work. So we're going to get into that now, unless there are any other questions. Okay, so don't panic. I am going to create a week 11 day 3 folder. There is no homework assignment for this. You do not need to turn this in. I would encourage you not to code along, which I know is rare for me, unless you feel like you're not going to understand these concepts unless you build something with it. At which point you are welcome to follow along with me. But like I said, I am encouraging you not to follow along today. So let me go to my code. Let me just create a quick day 3 folder and pop that open in VS Code and close out of this. I will start a live share. Again, it's not to make you panic or make you feel like you have to follow along, but if it's easier to read the code in the live share, you are welcome to join. And I'm also going to drop that in live stream. Okay. So I'm going to create my index.html, and HTML by default cannot make any API calls, right? That would be like saying, hey, let's get an API call to happen in our CSS. Nope. CSS is good for styling. HTML is good for structured markup to get our page to show however we would like. But JavaScript is the one that's actually running the code. JavaScript is going to be the one who makes the API call, brings that data back, lets us work with the data, and then we may want to take that data and incorporate it back into our HTML, which we're going to do tonight. But JavaScript's where all of our API magic is going to happen, although our HTML may take some of that API data and put it into our HTML. So I'm just going to do hello world. I'm going to save and go live and see hello world show up in my browser. And then I am going to create a new file called script.js. I'm going to save that. I'm going to go back to my index.html, and I'm going to add in a script source tag that's linking to my script.js. Hopefully most of this is familiar. Then we're going to go back to our script.js, add in a console log hi. I'm going to pop this open here. I'm going to go into my console. I see hi coming out, so I'm good to go. So step 1 is we need to make the request. Step 2, we need to parse out the request. Step 3, we need to get the data that we care about from the request. And step 4, we need to take that data and make it show up in our HTML. So let's code that out. Step 1, make the request. Step 2, parse the data from the response. Step 3, we need to dive into the data to get out what we want. And step 4, make the data show in our HTML. Someone define parse for me. What's parsing data?
Is it like not organizing it, but like sifting through it? I don't know how to say it.
Is it
So,
converting?
Yeah, converting is the way that I think about parsing out data, right? So JavaScript object notation, here's a loaded question for you. What data type does JavaScript object notation use?
Isn't it the data type?
Yeah.
The
It is
data
the
type.
format used to structure the data. However, when we use JSON, JavaScript object notation, what kind of data type is JSON?
An object?
Object,
You would want to say it's an object. It's
String.
not. It's a string.
String. God, well,
So
yeah, okay.
what we're doing is when we use JavaScript object notation, turns out APIs are terrible for sending any kind of data other than a string. The server is just expecting a string of letters to come in. But then when we set the content type in the headers, what that's doing, it's saying, hey, server, when that data comes in, it's going to come in as a string, but parse that string out back into a JavaScript object. No notation there, JavaScript object. Now, what happens when we want to do that in reverse? What happens if we have an object that we want to send up to the server using JSON? We're going to call JSON.stringify. And what that's going to do is take our real object that we're using in JavaScript and convert it using the JavaScript object notation. And it's going to use that JavaScript object notation to generate out a string for us. So what we're really doing when we're sending this data back and forth, we're sending all of the data in the request and all of the data in a response. That's all coming as a string. But we either need to parse that data to take the string and make it back into an object using this standard notation that is literally JSON, or we need to do it in reverse. If we've got some object that we need to send up to the server, we're going to stringify that data, which is going to take the object, use JSON notation, and make it into a string. So parse and string, two peas in a pod, right? Whenever we stringify something, we're taking an object or an array and turning it into JSON. And the reverse, if we've got some string that looks like an object that we want to actually be an object, the parse is what's going to convert that string out into an object. So yes, it is a very loaded question. You think JSON, JavaScript object notation, what kind of data type does JSON use? Well, it is representing, it is using the notation to show an object, but at the end of the day, JavaScript object notation is using strings to store that notation. Okay, any questions on that? Any questions on the 4 steps that we outlined here? Okay, so I'm going to show you 2 ways of doing this. It's going to be one of those things that we're going to make it work. We're going to pause for any questions. We're going to make it work another way, and then we're going to see which way you prefer, and that's how we're going to roll forward with it. So first things first, we need to make the request. What library or what JavaScript function do we use to make a request?
Was it like a let or a get or I don't know. I'm not sure.
Fetch.
Oh yeah, fetch.
Okay, and we're going to get started by fetching google.com. Then we're going to tell the computer, hey, when you have google.com, then I want you to give me access to the response and whether or not there was an error. And once you have that, go run this function. This function is going to give us access to the response and the error. And all we're going to do is console, then we are going to take it and we want to get the HTML out of that response. So we're going to say the HTML is equal to the response.text. Sorry, we're not. Once we get the text from the response, then we would get access to it from here. make sure this code works before I explain it. You crap. This example may not work. Should have tested this. Okay, we're not going to do that. We're going to go right to the Owen Wilson API. So I don't know if Ryan got into cores, but Google is basically saying we don't want any other web page to be able to load our web page in. So they're blocking me from doing that. So we're going to use the Owen Wilson API instead. Okay. So let's break this down. First things first, when we make the request, we have to know where we're making the request to. But before we can make the request, we've got to tell JavaScript, hey, we're going to go fetch something. Fetch is a library that is built in to the JavaScript runtime environment that the browser uses. And now it is also built into Node.js. So it is a way of saying, hey, this fetch is going to go fetch some data for us. And the fetch is going to make the request and give us access to the response. Okay, now we need to know where we're fetching. So what we're going to do is we're going to give it the URL. Where did I get this URL from? I went to someone's API documentation and they gave me this URL. So if I wanted a specific year, I would change the URL, change the request, change something different. But in this situation, we're just going to grab the multiple results URL. But our code runs asynchronously. That means that this code is going to run in the background because API calls can take a while to run. So to show that in practice, we have our console log here. I'm going to say console log first line of code. I'm going to come down here and say console.log after fetch. Let's actually say before fetch. And then we're going to come in here and we're going to say console.log fetch done. Okay, everything that we know about code is that it is going to run from the top down. So it should print out before fetch, then it should do my fetch and print out fetch done, and then it should say after fetch. If I save this and go look in my browser, I have before fetch, after fetch, and fetch done. Oh, that's kind of weird. That's not the order it is in my code. What this then is doing is it's telling the computer, hey, this fetch may take a while to run. So go ahead and finish running anything else in the file. But when your fetch is done, when we have the data, then I would like you to go do something. But only then, after the fetch is done, do I want you to do this stuff. So that's why we put this .then in there, because fetch is returning what we call a promise. It is promising that there will be data, and when that promise is fulfilled, then we want to go act on it and do something about it. So this API request could take 10 minutes to run. It could take a while for us to figure out what random Owen Wilson wow we want to show up. So what fetch does is it's saying, tell me then what you want me to do. And when that then finally happens, I'm going to give you access to it in the response. We then take that response, and if we console log out the response, we're going to see a whole bunch of data in here. It's going to have that body. It's going to have the headers that the server responded with. It has our status code of the 200. And it's got some other information in it, like the URL that we requested and fun stuff. Zach, go ahead with your question.
When you say it takes a while, like, or it can take a while, like, is that in like computer time or like human time? Like, does it normally take like 5 to 10 minutes to get like a fetch, or is it just like, I don't know, X number of like nanoseconds that's like long for a computer, but not long for like us, you know?
Great
I
question.
mean, obviously, like the code already responded by the time we saved it.
Yeah, so great question. The answer is it depends. So a fast API, we consider about 200 milliseconds in a response time is acceptable for an API. Well, that's a little bit more than acceptable. That is what's considered fast, but it depends. It depends on your internet connection, right? When I load the web page, it's got to go out on the internet. It's got to go find wherever this Owen Wilson API is. The API has to pick a random movie that Owen Wilson said wow in. Then it's got to send that data back over the internet back to my computer. So if I'm on a dial-up internet connection, that API call could take 5 or 10 seconds, or it could be super fast and go 200 milliseconds. There could be some processing that's required. An API that we use is called a text-to-speech or a speech-to-text API. So when we build our chatbots, we have some text that we would like the chatbot to read aloud, but that needs to be converted from the text string into an MP3 file that can play back the audio. So we actually send our text over to Google and say, hey, Google, please make this an MP3 file for me. And Google does that, but it could take Google 3 or 5 seconds to generate out that MP3. So our API could take 6 seconds to run because it could take Google 3 seconds to build that MP3 file, and then we've got to send that MP3 file back to the browser. So there are API calls that could take 3 or 5 seconds. There are API calls that could take hours to run. We batch send out emails, right, at the end of the night. And we're sending out thousands and thousands of emails. Well, that doesn't just happen instantaneously. That could take hours to run overnight. So API calls could literally take hours. It all depends on how fast the internet connection is that you're sending the request, how fast you can get that response back over your internet connection, and how long it actually takes the server to process your request, generate a response, and send it back out to you. So in this case, when we can actually look at the network tab. And if we refresh this page, you can see this random 200. This random ran in 121 milliseconds. That means from the time it took to make the request for the server to pick a random movie and for that server to get sent back to us, that took 121 milliseconds. Now, if you were doing this code and we're on a slower internet connection, this might take a little bit longer for your code to run. But like I said, anything under 200 milliseconds is considered a very fast API. But it does depend on what you're requesting that API to do.
Question: what's the longest time you have ever waited for a response?
3 weeks.
Okay, thank you. 3 weeks.
However, it is considered anything over a minute or two. Your browser is not going to do a great job of making sure that that connection is staying alive and that you're staying connected to your API server. So anything over, let's say, 60 seconds, there are alternative ways of developing your API to basically say, hey, I would like you to go start whatever this request is and tell me you have just started it. Tell me you're just working on it. And then every 15 seconds, I'm going to ask you, hey, is that done yet? Hey, is this done yet? And if you say, no, I'm still working on it, tell me what percentage done it is so that I can update that for the end user and say, I can say request in process, 2% done, 3% done, 4% done. And then when it finally is done, I can go in and make another request and get out the data. But that's very uncommon. I shouldn't say that's very uncommon. If you have an API request that is going to take longer than 60 seconds to run, there are better ways of architecting your API using multiple endpoints to make sure that your requests do not take that long to process.
As in, you could make multiple requests with specific, like,
Different endpoints sending different
endpoints
data
that you
in
need
order
instead
to
of a
handle
whole
that.
chunk.
Yeah.
Makes sense. Okay.
Larry, question.
Yeah, so does someone actually take the time to document every single spot in the movie where Owen Wilson said, wow, or they did that programmatically?
No, well, I don't know where they source the data. If you are interested in learning more, do I have that tab open still? I closed it by accident. This entire project was actually open sourced. So if you click on this fork me on GitHub, it's going to take you to the repository. And the repository has this wow arr.js, which is quite literally a 2,376 line array of every movie and all of the data related to it. And this is straight up JavaScript. And if you are curious about how this data makes it into the API, you could even go into index.js and it's going to show you how it handles the GET request to the random, has the request coming in and the response that it is sending the data back with, and how it is using all of that data coming in to find a random movie and return it back out. But do not panic. This is what we are getting to in like week 18, I want to say. We are going to cover how you do all of this and how you can build this from scratch. Might be a little sooner than week 18. But if you are curious, you can come in here and see how all of this works under the hood. And I know Ryan has also open sourced the API that he built for all of your homework to get the key to work and to be able to complete all the homework. Ryan actually has a server for all of that. But do not panic. We do not expect you to understand this. We will be teaching this in a couple weeks.
Thank you.
Any other questions before we start using our data here? Okay, so we've made a fetch request to this URL. We now know that because these requests can take a while to run, and a while could be anything from 20 milliseconds to 100 milliseconds, all the way up to 60 seconds or even longer, the fetch is trying to help us out. And it's trying to say, hey, tell me what you would like to do then once the data is available. Once the data is available, then what would you like me to do? And this dot then is considered a promise. And it's considered a promise because it is promising that that data will be available. And when it is available, then what would you like me to do? So it stores that data in the response. But when we look at the response, it's this weird thing with the body and the headers and the status code and all of that kind of stuff. So what we're able to do is say, hey, then go into the response and get out the text from the response. But parsing all of this text may take a while. So then once the text is parsed out, give me access to the text and console log all of that out. And what we get here is this giant block of a string.
Max, I know I asked this earlier. This was kind of where my question was, now that we're here. So at this particular point, what would be the difference in response.body or is it the response.text again?
Response, if we do response.body and log that out instead, response.body is not a function. So what if we look at this whole response and not just at the body of the response, we see this big object, right? And if we look in the body, it's coming in as this thing called a readable stream. So we could log out response.body. But what fetch is doing is it's saying, oh, response.body. it gives us this thing called a readable stream. But that is a readable stream that the computer knows how to understand. That's not something that we know how to understand. So there's an additional step here. Once we have access to this stream of data, we need to convert that into something we know how to work with. Now, if we do .text, it's going to give it to us as a string. Or if we do it as .json, it's going to try and parse the object for us and give us that object. But right now, the response.body is not something that we as humans know how to work with. It's just this stream of data that we need to convert either into text or into JSON or into XML or whatever data format we know how to work with. So the response.body isn't really workable here until we parse it out into either text or JSON, at which point we're able to work with the data in here. You're muted.
So I think I said it wrong. Can I share my screen real quick?
Yes.
All right. Can you see it?
I cannot. Try again. Oh,
I'm sorry. I didn't like double click.
There you go.
All right. So we were doing the New York Best Time Seller. This is what I came up with to get the information.
Yep.
So what's the difference between this and what you had?
So what you're doing is you are converting the response into text first. So you're taking the response, making the response into text, and then parsing out the body in using your JSON.parse. What I was doing is instead of using .text, I used .json, which is a parsing function built into fetch that allows me to convert it not only to text, but also do the JSON parse all in one step.
Okay, thank you.
So we could, we could make it text first, and then from the text that we're getting out, we could say console log out json.parse our text into an object using JSON. And so in here, we get access to the whole object. Or we can get a little tricky and skip the whole text step and go right into our object. So we can print out our object here and get the same exact data.
So I think I'm still confused. I'll try to figure out later. I'm still confused about the body part. Why use the body part? Like in my example, after we get the text, I don't know. All right.
So here, let me do this. What's happening here is the response.json is using the response body in order to send that into this thing called obj. We can call obj whatever we want. You happen to call it body here, but we could call that data formatted in a way we can use, as long as we called it the same way here.
So basically, it's just an arbitrary word, and we had, all right, I get it now. Thank you.
Yep. So what you were doing is you were calling response.text. Okay, now we have converted that weird readable stream into something we can use, but we then have to do something with it. So we're going to get it, and this right here is coming in as a string. So if we just console log out this string, we are then getting, this big thing. But this is a string. We can't just call .movie on this and get the data out. So what you did is you took the additional step of saying, hey, parse that out, parse out the string, and that string is really the body, right? The body coming back in the response. So what this is now doing is giving us access to the object and letting us dive into it. So you, instead of calling this string, you called this body. And what that body really is the parsed out response body converted to text. And once it was converted to text, it was a string, or the body represented as a string, and then you parsed it out here.
So no matter what I called it, the response.text is putting the body into the first parameter.
Correct.
Okay, thank you.
And so what I did down here is accomplishing the exact same thing, except it's combining the .text step with the JSON.parse. And what that .json is doing is storing that. Once it is done parsing, then I would like to get access to that object in my parameter.
Thank you.
Danielle, did I see a question?
Yes, but I think you answered it while you was going over what you just went over. Thank you.
Okay. So we made the request. Check mark. Now we need to parse or convert the data from the response. Well, we did that. We've got our object here, right? We've converted the data from whatever it came back as, this weird readable stream that only the computer knew how to work with, into text or straight into the JSON. So I'll just put it down here. I'm just going to comment these out so we don't. Okay. Now we need to dive into the data and get out what we want. So what I would like to show up is I'm going to look at this, and I would like the movie name to show up. I would like the timestamp to show up, and I would like a little audio player to show up of him saying it. Or let's get fancy. Let's use the video. I would like the little video clip to show up as well. So now we're going to take off our API hats. We're going to instead put on our JavaScript hats, and we're going to say, how do we get data from our JavaScript to show up into our HTML? What methods do we use, or what concept do we use to get data from our JavaScript into our HTML?
Document .get element by ID or something of that sort.
Absolutely, yeah. So what we're going to do is we're going to say, hey, we're going to put a div in here with an ID of movie data. We need something that we can hook our JavaScript into our HTML. So we're going to go say, hey, once we've got all of this data, document get element by ID. And the ID we want to use is movie data. And in that movie data, let's just start by saying, hey, something. So when we come over here, we see something showing up. Okay, well, we should be able to say, well, we've got this OBJ going on here, right? Let's look at our OBJ. It's in an array, so I know I'm going to have to use index 0. But right at that top of that array in this object, there is something, a key called movie. So what I would like to do is say, hey, there's going to be an H1 that shows up. And in that H1, I would like my object go into let's call this data. Go into the data coming back from the API. Go look at the first item that comes back, and from that item, pull out the movie. So we get the big bounce coming back. Well, where's the big bounce coming from? If we console log out our data, you can see we went into our data. We got the 0 index. So we went into our data, we got the 0 index, and then we pulled out the dot movie from that object in the 0 index. And we took that and we put that to show up in our page. All of a sudden, something get real? Did we get one light bulb moment?
Yes.
I'm
It's gonna
following.
be random every time.
Oh,
Question.
I have a question now.
The way this API is set up, Wayne, is it is going to be random every time. But that's because we're using this random up here.
Okay.
So if we wanted to, we could go back to our API documentation. And there are other ways of getting responses out. So we're using the random one, but there are ones where we can specify a specific year and get all of them that way. Or we could say, hey, we want a specific wow in the movie, or we want to get out the first time Owen Wilson ever said wow. So we would change our URL there to include that information.
Thank you.
And we could test with that before putting it in our code by going back to Postman, dumping this in and saying, hey, first time he ever said wow in a movie was 1996 in Bottle Rocket. And now no matter however many times I make this request, it's going to return out that movie. But if we wanted to see the 50th time he had said it, we could type in 50 in the URL and get out hall pass.
Thank you.
Christy, question.
I have a couple questions. My first question is, so now that I'm seeing this, so basically we're going to, I'm thinking ahead, we're going to fetch these bestsellers, and then we're going to, where you did like the H1, we're going to take some data with regard to the bestseller, and we're going to pull that data so it will show up on our page about the bestseller.
That is exactly what you are going to do.
Okay, second question is, for some reason, I was not able to get, my live share button is gone. And so I created everything in VS Code, but then there was no live share button for me to click on to be able to pull everything up. So I don't know.
Let me help you with that during the break.
Okay.
I think there's some weird thing where, like, if you right click down at the bottom, do you have a blue bar at the bottom?
Yes.
If you right click on there, do you see live share extension?
I do.
So click that on, and then did that get you your button back?
No.
Okay, I'll
Okay.
work with you on the break on that.
Okay, thanks.
Zach, let me answer your question in chat, and then I'll see if you have another one. So the $ curly braces is our template literal. So we use a template literal whenever we use a string with backticks. And the string with backticks is called the template literal. And what it does is it says, hey, stop reading this as a string. So we literally want the letters H1 and the arrows to show up. So those are not in the curly braces, but we don't actually want data 0 movie to show up in our string, right? If we want that to show up, it's going to say data 0 movie. We actually want you to go into the data object, to go look in the array, and to go pull out the movie title. So what we do is we say, stop reading this as a string and go get that data for me. So anything between the $ curly braces is going to say, don't read this as a string anymore. Actually go get the value out of this array, out of this object, out of this variable, whatever it is, and plunk it into our string. So if we actually look inside, this string, this H1 is taking the movie title, dumping it in between our H1s that we've added in.
Oh, okay, cool. Thank you.
So without the $ curly braces, it thinks it's just another string and is going to literally put in the letters DATA bracket 0. We can only use this $ curly brace syntax, though, if we're in a backtick. If we make this a regular string, it's going to be like, I don't give a crap about your $ curly braces. It can't be on multiple lines. It's going to say, I don't really give a crap about your $ curly braces. That's still going to show up. So the only way we get those $ curly braces to work is if we change our single or double quotes back to backticks.
So what should we think of backticks more for JavaScript, and then the other ones are just HTML, and just like put that out of our mind and just remember backticks?
So it's all a JavaScript string. The only difference is the backticks are going to set you up to use a variable inside. It's considered a template literal because it's literally trying to use this as a template to figure out what your final string should look like. So if you console log this out, you're going to see it comes out as a regular string. And it isn't always necessarily used with HTML, because if you say like const pet equals dog, you could come in here and say like the type of pet I have is a, and then put in the word dog. And that would also come out. If I use the right variable name, that would also come out as a string. So what the template literal is doing is it's saving us from having to do this. This line of code and this line of code end up doing the exact same thing. We're just using that template literal syntax to be able to reference the variable directly in our string.
Okay, got it.
Christy, go ahead.
So for the template literal, that's a more permanent solution, so that you're using that as you're coding along. Console log is like, okay, we're going to make it, we're going to see it, we're going to console log it so we can see it and make sure that it's working. But the template literal should be considered something that's very similar to console log, but it's a more permanent.
I wouldn't say more permanent. It's preferred because it's a little bit cleaner of a syntax. But if it makes more sense to you to write this as, hey, it's going to start with an H1, and then at that H1, we're going to add in the data from the movie, and then we're going to pick up where our string left off and close out the H1 tag. That and this line are accomplishing the exact same thing. It's literally just a way to avoid string concatenation and to be able to do it all as like, here's the template of what I want my string to look like, as opposed to, hey, we can start our string, we can add our data into it, and then we can close our string off.
Okay, I didn't think of it in that context. When you compared it to console log, that's what made me think.
Not comparing it to console log. All we're comparing is what is outputting from the console log. What do we want to console log out? There's no way to see that this thing and this thing are going to do the exact same thing unless we console logged it.
Oh, okay, okay, okay.
Okay, we are approaching break time. How are we feeling? Lots of good questions. Nicole, I'm not quite sure what you meant with consolidate.
I was asking if like it would be. It's not though, but
Okay.
yeah.
All right, so let's take a break. Gonna be back at 7:30. I know I'm an entire 8 minutes late on a break. You can give me grief in the 30-second feedback form later. But I will see you guys at 7:30, and I will stick around, Christy, and you can screen share through your problem.
Okay, let me see.
Any questions pop up during the break? Okay, we're gonna dive right back in. So if we look at our Owen Wilson response API in Postman, we're able to see this video object, and it's got this URL here, right? So if I just copy that URL, I can go back to my code, back to my index.html, and I'm going to use a video tag, which we haven't used before. So if I just do a search for video HTML W3, I can pull up the documentation, which is going to show me, hey, all I need is a video, and I'm going to put some controls on it. And then inside of it, I'm going to use a source tag to pull that file in. So what I'm going to do is I'm going to come outside of my movie data, and I just want to play around with this, right? I want to figure out how this is going to work without me getting into my JavaScript, and then I will add it into my JavaScript. So I'm going to add a video tag, and my video is going to have some controls that show up on it. And then I'm going to use a source tag, and the SRC is going to be that long NP4 URL that came back from the API. And then the type is going to be video. Video MP4. And I believe that closes out our source tag. So I'm just trying to see if I can get this working in my HTML before I move on to getting this working in my JavaScript. So I'm going to go live. And I get this super big video player showing up with my play button at the bottom. Okay, maybe we don't want it that big. So let's go and take this height and width. And I'm going to copy that, go back to my code. I'm going to paste that into my video tag. And let's make it 480 by 320. Okay, so when I come over here and I refresh, now it's a little bit more appropriate size. And if I hit the play button, I get the little clip that plays with the audio, right? So now we need to take this and we need to get it working in our JavaScript. So I'm going to take this whole video tag. I'm going to go back to my script.js. And instead of just putting in this H1, I also want to put in all of that video stuff that we just had in our HTML, except we don't want this URL to be hard-coded to this particular hall pass video. We want that URL to come from our data. Okay, well, where is it in our data? It is in the array at 0, and not just the audio. We want to go to the video. But hold up, our video is actually an object. We know it's an object because of that curly brace. So if we click that open, there are 4 different URLs in here, and we want this 1080p one because that's the highest resolution, right? So what we're going to do is we're going to delete out this entire URL, and we're going to say, hey, instead of the source being that MP4 file that we hard-coded, go to the data, go pull out the first movie in the array, go look at the video key, and pull out the 1080p version. Now, VS Code is yelling at me because whenever we use object keys that start with a number, we have to use the bracket syntax. So we have to use this. So now when we come over here, Shanghai Nights, here's our little video clip showing up from Shanghai Heights. And if we refresh, now we have the internship, and this clip is from the internship. That's it. Solve APIs. I'm done. See ya. I'm out.
All I can think of is every time I see him in a movie now, I'm gonna look for the wow.
We could even add in some things like total number of wows in this movie. And that is stored in the movie current wow in movie, total wows in movie. There were 5 wows in cars, and this is the first one we found. Or the one we found, I should say. And if we refresh the page, we get Marley and me, and there are 3 wows in that one. All right. How are we feeling on homework? Are we feeling like we can start to tackle New York Times? Are we thinking that this is on the right track? I'm going to share all of this in the live stream folder with you guys.
I'm feeling better because I kind of knew what I needed to do. I was able to get the data from the bestsellers list. And I think if it's the top 5 we need, I know there's a rank property. So I'm feeling better.
So I'm going to show you guys another syntax for this. Whatever one you use is completely fine and up to you. Let me see if I can get away with something really quickly. Pretend like you're not seeing me try this. No, okay. Okay, so there is an alternative syntax that we can use for promises, because the promise, whenever you see .then, you know it's using a promise. But we've got some complications in here, right? Because we actually have 2 promises going on. We've got the promise to go get the data. Then we have the promise to parse the response out as JSON. So now all of a sudden we're 1, 2, 3, 4, 5, 6 levels of indentation deep. That's kind of messy, right? To be going back into what we consider a callback. This is considered a callback because once it's done doing this data, it is going to call this function back into the forefront and run that code. But this kind of gets messy. So the powers that be that create JavaScript said there's a cleaner syntax we can use here. And that's called await. And that's basically saying, you know what? Just wait for this data to be ready. And when this data is ready, then we will store it in this variable and you can use it. Unfortunately, in order to make await work, we have to tell the computer, hey, heads up, there's some code that's going to run asynchronously. So the way we do that is we create a function. We'll just call it async function, and it looks like any other function. However, because it is in a function, we need to tell it, hey, go run our function down here. So it's just like any other function. If I console log something, I add in the word test. I come down here, and we see the word test come out. Okay, but now we can get fancy and say, hey, this function is going to have some asynchronous code going on in it. And because we're telling you in advance this asynchronous code is coming, we can also tell you, wait for that code to be ready before we move on to the next step. So in order to do that, we're going to add in the keyword here, async. And what this async is doing, again, is just telling our JavaScript, heads up, the code, when you run this, some asynchronous code is going to happen inside of it. So then what we can do is we can take our fetch, just like we were doing before, and say, hey, our const response is going to equal our fetch. Now, if we console log out our response, we're going to see this promise is coming in here, and it says promise pending. Okay, well, with the way we solved for this promise before is we put a .then on it. And that .then said, wait for that promise to have the data that we want, and then go ahead and deal with that data coming out of it. Well, what we're going to do here is, instead of chaining a .then on, because we have told it, hey, this is an asynchronous function, we can tell it, just await for the promise to be done. And once that promise is done, we're going to have access to our response. So when we come in here, we see now we get this readable stream. Well, wait a second, we were getting 43. Now we're getting our response. Wait, this response looks just like the response that we got from up here. Oh, so if we can use this fetch then trick and use await instead, can we do the same thing with our data? Our data is going to await for the response to have the JSON parsed. Oh, well, now when we log out our data, we get our data, and that looks just like this. So once we do all of that stuff, all of this code is going to be identical. So this asynchronous function is doing the exact same thing that this code is doing up here. The only difference is we're using a different syntax for our promises. So we can use then, and whenever we use then with a promise, we get into a callback, right? This fetch is waiting for the data to be ready. And when it is then putting the data into the response. And then once the response has the JSON parsed out, it is then going to put that into the data, and then we can work with the data. This is completely fine. This is normal promise syntax. But people hated the fact that every time we had another promise and another then, we had to go another indentation level deep. And they thought, hey, this code's getting a little messy. So this is the alternative syntax that they came up with. They said, instead of saying what to happen, then once the data is ready, then do something, we can instead use this await keyword. And what this await keyword is going to do is it's going to say, just hold up. Don't run any of the additional code until this is done. When this code is done and we don't need to await for it to be finished anymore, just go ahead and shove it into our data. The only catch, you can't use this await keyword unless you tell us, hey, we're going to run this code asynchronously. So this syntax is exactly the same. It literally is doing all the same work as this fetch with the then up here. It is just an alternative way of dealing with our promises. And instead of using then, we can use the await keyword. And that await keyword is going to store the result of the promise into our variables. I can smell your brain fires from here.
Max, when I typed that in VS Code, it puts parentheses around await response and then .json.
Let me see.
So right, already lost my place right here.
You've got two awaits there.
Yeah, but it's, yeah, it added the second. So if I say await response.json,
What?
when I
So-
make,
So
Yep.
don't hit the enter button there.
I'm not, I'm just hitting the parenthesis for the opening parenthesis.
That's. Can you give me remote control?
Yes. Oh, I gotta,
Yeah, you can do that quickly. It doesn't make you reboot Zoom for that one.
okay.
Lock in the bottom left.
Yep.
And then check off Zoom. And then I think I should be able to, yeah, I'm in. Okay, so it should just be response.json. That is very weird. I don't know why it's. Oh, you know what the problem is? You missed your await up here.
Oh, okay. Okay.
So that's actually very smart of VS Code. What it was doing is it was saying if you want to use response.json, you've got to await for the response to be ready. And then once the response is ready, then you can convert it to JSON and wait for that to be done.
Got it.
But it is much simpler just to await for that to be ready. And then once it is, you can just wait for the JSON to be parsed. Good to go?
Okay. Yep, I got it. Thank you.
So the thing that I would pose to you here is compare the code at the top to the code at the bottom and figure out, hey, which one do I like more? Which one makes more sense to me? Because if one makes more sense or is cleaner than the other, it's completely fine to use that. There is a industry preference to use async and await, but it is a newer feature. It is a feature that is even newer than const and let. So if the .then makes more sense to you, that's fine. If the async await makes more sense to you, that is fine. Either way, you just have to understand why do we need the .then or the async and the await. And that is because JavaScript is trying to run that API call in the background for you. We consider that asynchronously because two things can happen in the background at the same time. And so the .then or the async and the await is what is giving us control over that so that when we are running that code in the background, we can know when the code is done running in the background, then do something to handle it or wait for it to be done running. All right, how are we feeling? I'm going to request that everyone goes back to the form that we filled out last night. Which should be, they make it a homework assignment. No, I did not. Okay, so let me grab that link. It is from the week 11 day 2 outline, the self-assessment. It should let you edit this form. And once you get to that last section on APIs, go ahead and fill that out for me, of how you're feeling. If you're feeling like we've covered the things, if you're feeling like you're still a little lost, however you're feeling, go ahead and modify your answers based off of what we've covered tonight. Hopefully I pushed you guys into the next step up of if you're feeling vaguely familiar, hopefully you're feeling like, so now I'm in the middle. Hopefully that review kind of pushed you over the edge there. So I'm also going to start a poll in Zoom. All right, I'm launching this poll as well. Couple different places that we can go to from here. We can either go back to our weather project and work on layering in an API to actually be pulling in real-time data. We can start with the homework from the beginning of last week and kind of start working through that together. We can start the New York Times project together, or I can shut up and you guys can take the extra 35 minutes and start on your New York Times. I have no preference either way, so whatever you guys decide is okay with me.
I'm sorry, Max. Did you want us to fill out the whole form again?
No, there should be an option to edit the self-assessment. And if there isn't, check your email, because it should be in your email with a link to edit that assessment.
Okay, thank you.
And if not, it's not a big deal. I'll figure it out. But there were only 5 responses for those questions, and I think 14 or 15 for all the other ones. So I'm pretty sure it should let you edit it. It's just a matter of like getting to your existing responses. All right, we've got 7 votes in, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 students. So I would love to get to at least 12 votes. Ten votes in on Zoom. Nicole, what do you want to change your vote to? Or from and to, I should say. See, this is why we don't give you guys polls, because I'll share the results in a second. Go ahead, Nicole.
Oh, I would say I would rather start working on the New York Times, just because I didn't have a fully good grasp on everything. But I do now, but I'd rather start it so I can.
Okay. 11 votes in. Hopefully one more person votes. We've got 11 votes in so far and 13 students in class. This poll is in Zoom. This is in addition to updating the self-assessment on all the API concepts. Going once, Going twice on the Zoom poll, last chance.
Max, I can't find the option to edit my assessment form. I checked my email too.
Darn. I don't know that there's any way. Doesn't look like there's any way for me to send out like responses. Did anyone get an email after filling out the self-assessment form?
I did.
Yesterday.
I didn't choose the option for that.
I think you might
Oh,
have to hit submit a copy of my responses to me at the end of the survey.
oh yeah, I did set it to when requested instead of always. All right, it's not a big deal. If you can't get back to edit it,
You can change it if you make the response form. I feel better though. Like how you can send the responses to an Excel sheet or something or Google Sheets.
yeah, what I might end up doing is just splitting out those questions into another form and then having you guys fill out just that last section.
Okay.
But I can
Thank
worry
you.
about that after class. Okay, well, we have almost a four-way tie. But with Nicole changing her vote, I believe that puts New York Times ahead. So I am going to start the New York Times project unless there are any major objections. And if you would prefer to work on this on your own and not follow along with me, there are absolutely no hard feelings to jump out of here and just start working on it instead of following along with us.
We'll try to tackle it on my own. Thank you.
No problem. And I'm going to save the weather project for tomorrow. We're going to do a quick integration of that for tomorrow's class. And then I will switch over to the chat application. We're going to make a chat app from scratch because that is our major ongoing project of adding in the APIs for that, getting all of that working, doing the styling, all of that kind of stuff. So we will do the weather app and the chat app tomorrow. With all of that said, I will be in person tomorrow at Common Space. So if you would like to join us in person, you are most welcome to. But obviously, virtual is also completely fine. So whatever floats your boat. If you want to join us in person, great. If not, no big deal. And I will see you guys tomorrow. If you are jumping out and doing the New York Times on your own. Otherwise, I will start sharing my screen again and going through that.
Take care, everybody. I'll just take around, but I'll be doing it working on my own though. All right, take care.
No problem.
Thank you.
Any final questions before we jump into New York Times? Okey-doke. Okay, sharing my screen. We are going to, I'm creating a new folder and calling it NY Times Starter. I'm going to put that in my day 3 folder. And I'm going to pop open my New York Times Starter in VS Code. Let me just clean this up really quickly. Call this wow. And move this and this into here. And I've got that shared. Okay. I'm going to close out of this. I'm going to go over here. I'm going to say, okay. first steps of any project, what do we need to create?
HTML, style CSS, script dot JS, I think.
Yep. Index. My script. My style. And make sure they're all linked together. So I'm going to add my link. Rel is a style sheet. And my href is going to point to my style.css. And we're going to add a script tag to our source, which is going to go to our script.js. And in our body, we're going to add an h1 tag and say ny times. And then in my script.js, I'm just going to add a console log ny. And in my style.css, I'm going to target my h1 and make it fuchsia. Go live. New York Times is in fuchsia. That's good to go. The only thing that I am missing is my console. So I need to go into my console and make sure New York came out. And what that is confirming is that my index.html is my main file that is properly linking to my style.css, which we have confirmed because it is in fuchsia. And by linking to our script.js, I see my New York coming out. So I know everything is all linked together. Okay, from here, what steps do I need to do? Let me pull up the assignment. Okay, you need to get a API token to access their API, follow these steps to generate one. This will involve making a New York Times developer account, creating a new application in their system, and finally generating out the API token. The instructions above should guide you through this process step by step. If you run into any problems, don't hesitate to reach out. And then he says, after we get our API code, our API key generated, start by making a basic HTML page with our HTML head, body, and title. So we already have most of that going on. The only thing we'll change is let's make this New York Times. And I'm going to share my live stream with both of you, with all of you for that. Okay, so we've already got step one down. Now, step two, add a div to the page with an ID that you can target later. ID, div ID, my data is div. Okay, well, we can do that. I'm just going to add a div, an ID, and we're going to call this, I'm just going to call it data and close out that div. Doesn't matter what you call this ID as long as you're consistent with it and use that ID in your JavaScript. Okay, add a script tag. Inside, use fetch to make an HTTP request to this endpoint in the New York Times API to get the top 5 best-selling books. Note, this is not the URL that you want to make the request to. You need to read this documentation to understand how the request should be made. Now, while that sounds like a complication, it's how it works in the real world. You're never going to be given an API and said, here, figure it out. You're always going to be given an API that has some documentation. I've spent the past 3 days at work just writing documentation for our API that we have our clients use, right? It's not just enough to get your API all up and running. If you're telling someone else to use your API, you have to tell them how to use that, and that's going to be all in the documentation. So let me pop that open in a new tab. And here is the documentation. And what it's saying is, this is the request that you're going to make. And that request is going to get the top 5 books for all the bestsellers for the specified date. Okay. And the published date is going to be some query parameters. What would be another kind of parameter that we could send other than a query parameter? Where else can we send data in our request?
I don't know, maybe like JSON, get, I don't know.
Where do we put the JSON?
In the curly bracket.
Not Postman, right?
Anywhere we're making a request, what are the 3 major places when we make a request that we can put data? We already said one is the query parameters.
A literal, I don't know. No,
Take it all the way back to our slides. The 3 places that we can put data
Curl.
in the request are either in the header of the request, in the body of the request, which usually is JSON, not always JSON, or in the query parameters. So lots of different places we can sneak data in. The query parameters are going to be the question mark equals at the end of the URL. So it is then telling me, hey, if the response comes back with a 200, we know 200 is okay. That means our request worked. It is going to have the entire body of the list and the list ID and the books that are inside of it. So if we come down here and we hit execute, it gives us a 401 unauthorized. Well, why? I'm in here, all I'm doing is trying to get the top bestsellers, the top 5, and said failed to resolve API key variable with request query param API key. Detail error code failed to resolve API key.
Gotta get a authorization code and use that bearer authorization.
So all the way down here at the bottom of the documentation, it says authentication requirements, API key authentication, key location query parameter name API key. Okay, so what did Ryan tell us to do? We skipped all the way down to step 4 or step 3. And what did he say up here? We have to make a New York Times developer account, create the application, and generate the API token. Okay, so I'm going to go sign in. I'm going to see if I already have an account here. I have to create one if I don't. Doesn't look like I do, so I'm going to create an account. Go to my email and go verify that account. And this is a very common flow. I just went through these same steps on I just went through these same steps to get the weather API working, which we will go through tomorrow. Okay, so now if I go back to there and I go to sign in and I sign in with my account. I'm able to go to up here and go down to my apps, create a new app. And I'm going to call this June 8th class. And I'm going to say I would like information about the books API. So I'm going to enable that. I'm going to come all the way down and I'm going to hit save. And here is my API key and the secret that I need to use with it. Okay, so I'm going to go back to the link that Ryan sent us to. And I'm going to now click the authorize button. And it's going to say, please select app. I'm going to click the app that I just created and hit authorize. And it needs me to add in. I said, okay. Execute. Ah, okay. Got data. All right, so now all of that is authorized, but this is just their playground. This isn't helping me get this working in my code or in Postman. So let's do this incrementally. Let's try and get this data working in Postman. I'm going to take this HTTP request, go back to Postman. I'm going to open a new tab and paste that in and then hit send. And I'm going to get that same issue, failed to resolve API key. Okay, well, they said the authentication requirements are an API key authentication, but look where it's telling me to put this key in the query parameters. How do we use query parameters? Where do our query parameters go? The end of the URL that we're requesting, right?
Oh, yeah.
Okay, now it's got to tell me, well, what's the parameter name? I need to know what the key is. So I'm going to take that parameter name and copy it and paste it in here. And then I need to get my API key itself. Zach,
Wait.
go ahead with your question.
Yeah, sorry, I fell a little behind because it wasn't letting me log in. Let me see.
Christy, why don't you go ahead with your question and then I'll come back to you, Zach.
My question is, why are you using the, wait, I thought we were going to use a slash. Why are we using a question mark?
Question mark is always a query parameter.
Okay.
And then if we had multiple query parameters, like if we wanted additional data sent in here, we would use an ampersand and say like pet equals dog. So the question mark is the start of our query parameters. The question mark is telling the browser, hey, we're sending in some additional data. We still want to get the overview list, but we need to give you some additional query information in order to get that out. And so we're going to send in API key, but if we needed to send in something else, we could use an ampersand and then we can use the key and the value for the query parameter.
Oh, okay, so ampersand. Okay, let me write that down.
Zach or Nicole, did you have a question?
I did. I fell behind too. I was trying to follow you as well. So I'm at the part where you put in June 8th class in the description. So do I just copy both the key and the secret? Or do I save it first? Or I just want to make sure I'm doing this right before I get lost again.
So save it. Saving is almost never a bad thing. I actually do not know how to use the key and the secret. So I'm going to copy this API key and I'm going to go back into Postman and I'm going to paste it in here.
Okay.
And I'm going to hit send and great googly moogly, we've got data.
Okay. You did okay. All right, I'm gonna try to do that. I don't know where my my Postman went.
Yeah, so let's take a break there and start a poll. The goal at this point is that you should have your app created in the New York Times developer portal, that you can copy the key here you can go back to the documentation that Ryan linked us to, and you can take this URL, then go back into Postman, and using the query parameter, which is documented at the bottom in here, you can use the API key from your app, pass that in, and get data out in Postman.
Did you go up to your query parameters?
Yep. Nope, apparently I can't. There you go. So I didn't add these query parameters in through this interface. I instead used a question mark, added my API key in equals, and then I set it in. Now, Postman was smart enough to say, hey, those are query parameters. I can make them show up for you here. But it's better to get that practice of coming in and doing that yourself, because there is going to be no query parameters interface in fetch when you go to set all of that up. When you are trying to get your query parameters to work in fetch, you're going to have to use this question mark and equal syntax. So you might as well get some practice with that. Stephanie, I saw a hand raise and then you slowly lowered it sheepishly. Still have a question?
Yeah, I was lost on where you were getting the API New York Times link, but I found it.
Beautiful.
One more question.
Yeah.
What's the secret?
What?
The secret. There's an API.
Yeah, I'm guessing the secret is only used if you're using another kind of authentication, or maybe it's a requirement for a different section of their API. I was kind of confused myself as to why there is a secret, but I bet you if we go back to their home and look at their getting started. Nope, that didn't give me any more information. And look at their APIs. Nope, I've got no idea why we need a secret. And it's not in their FAQ. No idea what the secret is for.
Might be for something else.
Yep.
A really
Christy,
quick
go ahead. And then I'll come to you next, Nicole.
Ryan said this was going to be hard. That wasn't hard. So I feel like so there's 4,910 lines of code that I scrolled all the way down to the bottom. So this is where we're going to basically do what you did for the movie.
That is exactly right. So what we did in the movie API, or I'm sorry, in the WoW API, which I guess is a movie API, same thing, right? We used the data coming back, and we had to parse the data out into JSON. But once the data was parsed out, we were able to use that data to dive into the array and get out the movie and the total wows and all of that stuff. So you need to follow these same 4 steps. Make the request, parse the body into the text or into JSON, which is what we did here. Then you need to dive into that data to get out what we want, which is what we're doing right here.
Hold on, parse the data. Parse the data or parse the body? Parse the body or parse the data?
The data is going to be in the body.
Okay, parse the data.
And it's going to be in the response body to get super verbiage correct. Then once we pull the data out that we want, we need to make the data show up in our HTML. Zach, go ahead with your question.
I'm getting a failed to resolve API.
Go ahead and share your screen. you are missing an equal between key and the actual API key.
Mhm. Okay, cool.
Ah, magic.
Thank you.
Is mine's
Hopefully
just-
Ryan doesn't watch this class because he's like, my favorite thing is getting them to figure out how the API key works. And it's like, yeah, but they really need that to like get the rest of the project working. Stephanie, go ahead.
I am.
Oh, sorry about that.
It's all right.
Okay, so I did the question mark API key equals, but then I'm getting invalid API key.
You're using your secrets. Secrets are no fun. Go back to your New York Times page
Oh, what did I do with it?
and go click on your email in the top right and go to apps. And then you took click on okay, there you go. And then click on careers in code 3 and you used your secret or your app ID. What you need to do is not use that or that. You want this one.
Hold on, isn't that
Oh, that's the key.
that it? That is the one I posted here.
Nope, that's look,
No?
that's your app ID. That isn't your API key. See how it has dashes in it? The key is the one we want to use.
Oh, okay.
Now, why do they have an app ID and an API key and a secret? No freaking idea, but I'm sure the developers had a great reason at the New York Times for needing all three.
Oh my
Thank you.
God.
All right, I know there's 5 minutes of class left, but I'm hoping that you guys can get started here using the WoW code that's posted in the live stream, following that along, knowing what we've got working in Postman, starting to work through our data. A reminder that you can use either the promise syntax with the .then, or if you think the async and the await syntax is a little bit easier for you to understand, that is completely fine. Whichever you prefer to use, you go for it. That's up to you guys. But hopefully you've got a good starting point for what we covered in class, what's working in Postman. Now it's just a matter of putting it all together. With all of that said, are there any homework questions on any of the other homework assignments? Did anyone get stuck and need a little bit of a help, a little bit of a push on anything other than the New York Times?
Yeah, you want to help me with some free code camp?
Sure. Not what I was asking for, but also happy to help you with that.
Oh, then I'll save it for a one-on-one.
I mean, if no one else has questions, I'm happy to do free code camp.
I have a question about this might be a one-on-one or maybe not, but I have a question about that the button for the tic-tac-toe.
Okay, probably better as a one-on-one.
Okay.
And I'll dump my link in the chat just so it's easily accessible. It's just my name / Cal. So, Nicole, let's go through your free code camp only because I'm guessing it's going to be a relatively quick one. Okay, so you're trying to access my var right here, and you're trying to access it here, but where did you declare my var?
So I have to do equals. Or do equals here?
Mm-hmm.
My equal button not working. Hold on a second. Equal.
Yep.
backspace equal? Would it just equal itself?
No, let's scroll down on the left side of the page and let's see what they're telling you to do.
Okay, my backspace is not working now. Shh, for 2 seconds.
The code should not contain a global myvar variable. You should add a local myvar variable. How do we add a new variable?
You just put a random word in there.
Nope.
I'm not sure.
Okay, if I want num to equal 5, what do we have to do to get num to equal 5?
Equal sign.
Yes, we do. But whenever we have declared a new variable in any of our code, the first time we make
like
that
the let
variable.
For okay, so like const myvar equals.
Yep, that's fine.
Const equals myvar.
Is that the syntax we've used to declare a const variable?
What?
So what we need to do here is you don't understand the syntax for how variables are working. So you're not going to understand any of the concepts after it until you've mastered the variables. So what I would do is I'm going to request remote control. I would take a step back here because the problem is not understanding. Yep. The problem here is not understanding how scope is working. The problem here is that we're still struggling with syntax of how to add that variable. So I'm going to go back to the curriculum and I'm going to go back to JavaScript algorithms and I'm going to find the first time we declare a JavaScript variable. And declaring that JavaScript variable, they're going to say var r name, and then and then it just ends, right? So we're going to say var my name, and we pass this one. Okay, but now what's the next one? The next one is storing a value with the assignment operator. Okay, so we have to declare the variable first, and then we can set a value to it. So we've already declared variable, the var a. Now we need to store a into 7. Okay, now a is 7. And finally, we can do that all in one step. So we can say var a equals 7, and that's going to be the same thing as saying var a and then setting a into 7. So whenever we declare a new variable, what they're trying to say is okay, they told us, hey, we need to add a local variable called myvar. So in here, the way that we make any new variable is we say var, myvar, and then we say, what is myvar going to equal to? Myvar is going to equal, my string. Now, when we run it, we get it to pass. What they're trying to get you to understand here is that because var myvar is inside of this function, we're only able to access myvar inside the function. We're not able to access myvar outside of the function because it was declared inside of that function. Now, what we could do is we could use a const or a let here, and any one of them would be acceptable. But we have to understand how we declare a variable and assign a variable before we're able to understand the concept of scope.
That was helpful too, Max. Thank you.
No problem. Larry, go ahead.
Thank you.
Can't hear you, Larry.
Zoom. I need to share my screen.
Yeah, go for it.
Okay.
Class is over, guys. So if you want to head out, you are welcome to. But I will stick
I'm on
around and
desktop.
answer any additional questions.
New share desktop too. Can you see my desktop?
I sure can. I'm liking what I'm seeing too.
Okay, so minus this, I was able to print the results and of the movies. But when I try to run through the results and print out all the rankings, I gotta share my other screen. Now I get an error in the console. Let's see. So it gives me the results. Let me refresh. So it gives me the results of the 20 movies.
Yep.
Then it gives me some of the movies and their rankings.
Yep.
And then it gives me the error of an uncaught in promise type error.
Okay, go back to your code for me.
Okay, share. And it said I was on line 17 and the rank was the issue.
Okay, so what I would do is I would console log out the entire movie before line 17, because what I believe you're going to find is that some movies may not have a ranks history. And that would be the case if this is the first week that it's on the bestsellers list. There's going to be no history of where it was at before then.
Okay, makes sense. I did see some that had like, yeah, two rankings. All right. Which, let me see.
So
Which one?
now it's going to print out the first 10 movies, right? And then when it hits movie 11 that doesn't have the rank history, I think you're going to find if you open up the console log that we just added in, you're going to see that the ranks history key doesn't exist, or it's going to be something like null.
It looks blank. Yeah, all right. Yeah, so this one book is blank. The $100 startup. I actually have that book. But yeah, it doesn't have a history in it.
So what you could do is you could say something like, if movie.ranks history, then console log out movie.ranks history 0.rank.
Oh, okay.
And that if statement is going to check to see if the ranks history exists. And if it does exist, then console log it out. The other thing you could do is you could put that console log in a try and then say catch whatever error happens and just console log out the movie title if you tried to access the ranks history and ran into a problem.
Okay, thank you.
No problem.
All right, take care, everybody.
Last call for questions.
Good night.
Good night.
Night, everyone. See you tomorrow. I mean, in person tomorrow as a reminder.
Good night.
See you guys.